Hello and welcome back. This is a continuation from the last video. So last time we looked at ion stability. Next on the list, we're going to look at something called ionization. You guys have already heard of ionization before in terms of ionization energy. And ionization energy is basically the amount of energy that you need to apply to an electron so that you can remove it away from an atom. So it's not a surprise that when we look at ionization here, we're going to look at it from the form of a reaction. Okay, so let's say that ionization is a process for creating ions. Okay, both cations and anions. So again, let's take the lithium atom that we just looked at. Okay. So in the previous video, we said a lithium atom will tend to lose its electron. Okay, so to write it out as a reaction, we generally take the neutral atom, okay, and because it's a metal, it will tend to lose its electron. So on the other side here, we're expecting two products. Once it loses an electron, we expect it to have a plus charge, and that one electron that it lost is now separated from the ion. So we have a cation being created, and we have an electron is quote-unquote lost. So electron is lost. Okay. This is typical for forming cations. So the number of electrons also have to cancel out the positive charge. Okay, so if we have one negative charge here, we have to have one positive charge. Okay, because the product right now is neutral because the two charges cancel out, and your reactant is neutral. So both sides of the reaction have to have equal charges. If we look at an oxygen atom, okay, here we have oxygen gas. Now, oxygen gas is a nonmetal. And again, it's a neutral nonmetal atom. In this case, because it's O2, I guess it's better for us to say molecule, but I'll go molecule like this. Okay. All nonmetals have to gain electrons in order to form ions. Okay, and the way that this is set up, if I told you that you are going to create an ion, and that ion has a 2 negative charge, like that, what would you have to put into the blank? Okay. So one of the things that you have to remember is that when you're balancing out charges, you also have to make sure that the number of atoms are balanced as well. So since you have two oxygen atoms here, okay, to make up this one molecule of oxygen gas, you're going to need a coefficient 2 in front of the anion. Okay, so if you have an anion here with a -2 charge, and you have two of them, well, what's the total number of charges? The total number, or total charge, is -4. So that means on this side, I actually have to gain 4 electrons, okay? Because each atom of oxygen gains 2. And because there are 2 atoms of oxygen, the total number of electrons has to be 4. So since you have the negative charge here being 4 on the reactant side, the positive charge, the product side has to also have a -4 charge. So as long as both sides have the same charge, then it's fine. Okay, so we don't always have to have neutral charges on both reactants and product sides. The common thing is we have to have equal charges on both products and reactant side, and that could be any value. Okay. Now, I'm going to quickly try to go over some applications of ions here. What do we use ions for? Okay. So if we take down a trip down memory lane here, in grade 10, you guys have basically used ions and were introduced to ions, right? But ions created compounds, okay, ionic compounds. So ions can form ionic compounds through chemical reactions. See grade 10. Okay. So something like this is probably common. You might have something like lithium ions, okay, and you're given the state that they are in aqueous, and you add it to chlorine ions, and you would then synthesize lithium chloride. Right? So this substance here is an ionic compound. And then in grade 11, you kind of did the opposite. Okay, you took ionic compounds and basically you dissolved or dissociated it in water. So they can dissociate / dissolve in water. And again, in order to show that, we could take something like calcium sulfate. Okay. Calcium sulfate as a solid, if you add water to it, like this, okay, you're basically splitting the two metals and nonmetals apart, okay, to form Ca2+, which is aqueous, and you have the complex ion of SO4 2-. That's also aqueous. Okay, so you've made a solution. So a solution is made. Now, what you're going to learn in grade 12, there is a particular type of reaction that deals with ions and such. We'll get to it a little bit later, but I do want to introduce one term before the end of this video, and this is basically a term called electrolytes. So ions are also called electrolytes, and electrolytes is a word that I think many of you would recognize, and you probably associate it with products such as Gatorade, because they have commercialized this product as a substance that contains electrolytes, and apparently electrolytes are good for your body, okay, especially when you exercise. But all it really means is you're using ions, because that's what electrolytes are. They're just another fancy way of saying ions. So in sports drinks, particularly, they're specific ions. So we'll say commonly found in sports drinks, or any substance containing dissolved salts. So for example, Gatorade contains Na+ ions, as well as potassium ions. And the sole purpose is for muscle use. So in a future video, we'll actually look at how these electrolytes are actually important and what they can actually do. But for now, I just wanted to introduce it. So just to summarize, okay, we've gone through how to create ions, okay, how stable ions can be, okay, how they lose electrons, how they gain electrons, how we separate compounds to form ions, how we use ions to form compounds. Okay. This first part of the aqueous solutions unit requires us to use ions quite a bit. So consider this to be your introduction to aqueous solutions, and in the next video, what we'll kind of look at is we'll look at special solutions that contain special types of ions. And that kind of sets the tone for the rest of the year, actually. So until then, I will see you next time. Goodbye.